All right, so here we are with lesson 2 of our nuclear chemistry unit. In this one, it should be relatively short. We're going to talk about artificial transmutation. And we're also going to talk about 2 things that you guys probably think of when you think of nuclear mutation. And we're going to talk about, so those are fission and fusion reactions. So these are things that people typically think of when they think of nuclear chemistry. So let's take a look at artificial transmutation. So this is a transmutation that occurs from the bombarding of a nucleus with a high energy particle. So we have 2 types. We spoke yesterday about natural transmutation, in the previous lesson about natural transmutation. It happens naturally in nature. This is like our carbon decay and our uranium decay. So artificial transmutation is we are doing something to occur that breakdown to happen. So the differences are with artificial, there's always 2 reactants, right? So we have our nucleus, and then we have what we are bombarding it with. In this case, it is an alpha particle. Or that helium, remember, that's an alpha particle. And it's not spontaneous. We are making this occur, right? So we are throwing at high speeds, high heats, high intensities, alpha particles at this aluminum and causing it to break down. So again, not spontaneous. Whereas natural, it's only 1 reactant and it's a spontaneous decay over time. So we have our types of nuclear reaction. So there is what's called a mass deficit with these reactions. So it's the amount of mass lost when you compare the actual masses of protons, neutrons, and electrons in an atom to the atom's actual mass. We then take this and we convert it to convert it to energy using the formula E equals mc squared. Right? So we have this type of energy, it's called binding energy. This is the energy that's holding those subatomic particles together. Remember, our subatomic particles are our neutrons, protons, and electrons. Right, so small amounts of mass can be created into large amounts of energy, and we can harvest this energy that comes from fission and fusion reactions for everyday use in energy. So let's start talking about fission. So fission is a neutron is shot at a radioactive source and it's split, which produces energy. So we're taking heavy nucleuses, so we see uranium-235, and we're bombarding it with something. In this case, in the first part of the reaction, we were bombarding it with a neutron. And then the next step, it kind of decayed a little bit on its own. And then after that, we had used, it looks like gamma rays in the picture above to break it down even further. So you can kind of see how we're going from 235 as our mass number. So this is a heavy nucleus. Rays are coming in, energy is coming out. And if you see, we have 90 as our mass number here and 143 as our mass number here. So we're getting smaller. The energy that's being released can be harvested from a fission reaction. But we've used fission reactions historically in a different sense. So these neutrons that are coming off, that are being released, if they're not controlled, we can get what's called a chain reaction, which is a series of reactions where each reaction is initiated by the energy of the previous reaction. So energy is also produced, so we need to always remember that. So this is what's happening in a nuclear bomb. So we've used fission historically in this sense. So we have, uranium bombs. So again, uranium, it's a heavy nucleus. We contain it and we cause it to react and it just keeps going. So it breaks down into baryon and krypton and then it just keeps going down the line. So it's uncontrolled reaction. But we can also use fission to generate energy. About 20% of our electricity in the United States is generated by nuclear fission. We are one of the largest nuclear power producers in the world. It's us, France, and Japan. Imagine nuclear-powered cars. We can have fuel cells that are the size of pencils, 1,000 20-gallon tanks of gasoline. We can make that much energy in a small, compact, almost battery type thing. Refuel every 1,000 weeks. So that's every 20 years we would be refueling if we could run our vehicles on nuclear energy. So this little blurb over here, if you want to pause the video and just read it, these are just some interesting facts about nuclear reactors and the energy that we produce with them. So that's fission. So now let's talk about what's happening at the sun. This is called fusion. So it is involved the combining or the fusion of nuclei to produce heavier ones. So now we're going from a lighter nuclei to a heavier. So one possible series of reactions is the fusion of hydrogen to form helium and release energy. And we can see it in this reaction series below. So first we have two hydrogens combining together to form another hydrogen, and it's releasing some energy. So two hydrogen has isotopes as everything else. So with a mass of 2, it's deuterium. That's our hydrogen. So now we're taking that hydrogen with a mass number of 2 and adding it to another hydrogen to get that mass number of 3, which we know is helium, right? So now we're going to take those heliums and combine them together to get even heavier helium plus hydrogen as a byproduct. And we can keep doing this cycle over and over and over again to harvest this energy that comes off at the end. So right, we see in this picture here, hydrogen atoms combine to form helium in a star. So this is what's going on in space, forming our stars. It's happening on the sun as well. So fusion reactions, they all produce so much more energy than a fission reaction, but they're very expensive. They're also very dangerous. The materials are more readily available. We have hydrogen in our air as we speak and as we breathe. There's less waste and there's less danger. There's no chain reaction. So the biggest thing here is it's way too expensive for fusion, even though it produces more energy than a fission reaction. All right, so this, guys, was short and sweet, kind of to the point. Fission, fusion, artificial transmutation. There'll be a quick castle learning or some kind of assignment that goes along with this, so keep your eyes posted there. And when we come back for lesson 3, we'll talk about half-lives.